Session border controllers, also known as SBCs, provide secure, controlled connections for SIP signaling and real-time media streams between IP networks. SBCs ensure that real-time IP communication services can be delivered securely, without hindrance, and with high quality between peered service provider networks and between service provider and enterprise networks. SBCs deployed between two peered service providers, whether wireline or wireless, are called peering SBCs. SBCs deployed between service provider and enterprise networks or consumer subscribers are called access SBCs, while SBCs deployed within an enterprise are called enterprise SBCs. While the basic functionality is the same, each type of SBC has different performance and scalability requirements. In the early days of voice over IP, SBCs focused solely on providing connectivity and security between peered IP networks. However, as service providers and enterprises began deploying more advanced real-time applications over IP, like unified communications, video, instant messaging, and conferencing, SBC functionality began to grow. Today, besides connectivity and security, SBCs must also provide advanced call routing, session admission control, session quality of service enforcement, fax and media interworking, call preemption and media forking for regulatory compliance, and call detail records for accounting purposes. The driver for the expanding role and growing importance of SBCs has been the exponential growth in IP network traffic, currently projected to quadruple between 2009 and 2014. Online video is growing at a rate of 300% per year, and the number of smartphones will double to over 500 million by 2014, greatly increasing mobile data usage. As IPv6 becomes more widely deployed, SBCs will also need to provide high-performance IPv4 to IPv6 interworking. All of these trends require SBCs to independently scale across multiple dimensions. Session processing and routing at scale requires powerful general-purpose CPUs. Packet processing and manipulation at wire speed demands dedicated network processors. Media interworking and transcoding at scale can only be achieved with dedicated DSP resources. First-generation SBCs, products that originally came to market almost 10 years ago, continue to perform these tasks on shared processors, an approach that simply can't scale to handle the flood of new real-time IP traffic. To address these issues, Sonus has developed the NBS 5200, the next generation of border control. The Sonus NBS 5200 is the first product to address the performance and scalability requirements that first-generation SBCs cannot. Based on Sonus's new Connects IP architecture, the NBS 5200 uses the latest generation of general-purpose CPUs for advanced call control and routing, the newest network processors for wire speed packet processing, and scalable onboard DSPs for media interworking and transcoding. The NBS 5200 is further powered by two critical software components. First is the mature, widely deployed Sonus Network Border Switch, already proven in over 80 service providers around the globe. Second is the Sonus PSX Session Routing and Policy Engine, the most widely deployed and advanced policy and routing engine in voice-over IP networks today. The NBS 5200 also includes local accounting functionality and native element management for complete turnkey operation. What would have taken multiple repurposed first-generation SBCs is now integrated into a single NBS 5200, providing end-to-end functionality in a single, cost-effective, highly scalable platform. With the NBS 5200, Sonus delivers the next generation of border control, and with it, the following crucial benefits. Industry-leading performance along every axis to ensure that scalability in one area doesn't adversely impact performance in another. Reduced total cost of ownership, as a single NBS 5200 combines border control, signaling and media interworking, high-performance transcoding, session policy and routing, accounting, and element management into a single, easy-to-configure product. Forward-looking functionality for emerging real-time applications and network features, including unified communications, rich communication services, high-definition voice, telepresence, and IPv6. Finally, it's all backed by the proven reliability of Sonus, the company that powers 40% of the world's IP voice traffic. To schedule a demonstration or learn more about the NBS 5200, please visit the Border Controls section of www.sonusnet.com.